Everyone. Welcome everyone to the TE Academy study season. We'll kick off track number 7 today with Giuseppe. This program is TE Academy study season, the first cohort-based program we are running with students from around the globe, offering RT fundamentals, bachelor level program, as well as 8 live tracks in total, where our students can meet token engineering researchers and practitioners in this new field or related fields like Giuseppe today. You can find our program at tokenengineering.net. For those who are joining us via Twitter or YouTube, you can still register. Just follow the link tokenengineering.net, register for the study season, and you'll get access to all the learning materials. You can even earn NFT certificates to prove your newly acquired knowledge. Now, today's session is about dApp analysis, exploring the complex systems-oriented approach, a new approach to analyze decentralized app systems. Pretty excited for this session. And before we start, we'd like to give you an overview on the where, what, and how, and run a brief introduction round. Then we'll start the first session with Giuseppe exploring the complex systems-oriented approach. And of course, we invite you to come to our Discord and follow and continue the conversation there. Where, what, how? For those of you who have been joining other sessions in the live track program, you are probably familiar with this information. There might be some new students. Let's help them to understand how this works. The sync meetings take place on Zoom. We'll have sessions in live track 7 on May 10th, today, and then next Monday. So this deviates slightly from, we usually meet once a week. In this case, track 7, we meet on next Monday and then continue with Friday sessions on May 17th and May 31st, always afternoon sessions, 3 p.m. UTC. So mind the calendar. Then we'll have async discussions on Discord. We'll have a track reserved for track 7, where we'll share material, we'll share the session recordings. You can work async, you can continue the conversation, collaborate on homework assignments, or dive deeper into the topic, reading through papers Giuseppe will share with us. And finally, you'll have either exercises, homework assignments, or exams to acquire an NFT as a proof of knowledge. We'll get to this in a moment. Now, first, our culture and values at TE Academy. We have the community guidelines available on our Discord. You can find them, read through it. Then, in addition to that, we invite you to be proactive. So there are no issues that we can't solve together. Reach out to your fellow students anytime. There are also no stupid questions. Just ask away. Feel free also to schedule additional learning sessions in your time zone with fellow students. And just be mindful when asking for support and say thank you, praise those who supported you, and keep in mind to give back whenever you have the chance. Minting NFTs. TE Academy has established a system of proofs of knowledge and contributions to this new native field, new crypto native field of token engineering. And you can become eligible to receive your own proof of knowledge for this live track by passing an online exam. This online exam will be available from May 30th. So after the final session, and then you'll have time to pass it. We'll keep in mind that you can collaborate, and actually it's not a bad thing to collaborate on the exams. So again, an online exam, by passing it, you will be eligible to mint your NFT. All instructions, anything you have to know about minting will be available on June 6th. until June 20th, which will then also be the period to vote on the fellowship winner. Because I should not forget to mention that Giuseppe is one of the fellowship candidates for the first fellowship prize of TE Academy to award most outstanding valuable contributions to the field of token engineering. And he'll share his knowledge in the spirit of give and get. And then you and the total token engineering community can vote on the fellowship winner. We have in total 4 candidates, more in a moment, and you can vote on the winner. And the more NFTs, meaning the more knowledge a voter has acquired in token engineering, the more weight this voter can accumulate. Overall, we have minted more than 1,000 NFTs so far with different degrees of, let's say, signaling token engineering experience, with the TE fundamentals, NFTs for the online courses, with the live track proof of knowledge NFTs minted now for the first time, and with other NFTs, for example, to course authors or to speakers at our events. And these NFTs will have different voting weights. Your fellow students, maybe some of you even will work on the design of this voting system. We share also more details once we have defined the final voting mechanism. And this way, we make token engineering knowledge count in the voting for the fellowship winner. You can find this information and more information on the Study Season Information Hub. It's a Notion page with all information, the calendar, all sessions, all track information. We'll share the links to the recordings, to the session material there. So always check out this information hub whenever you need anything related to this live track. And now it's time for the introduction round. So I'll ask you guys and Giuseppe to just switch on your mic, switch on your video, just say some words about yourself, about your background. Let's help Giuseppe to get a picture of the students in the room and introduce each other. And first, Giuseppe, the stage is yours. What brought you to complex systems and dApps, and what's your background?
Thank you very much, Angela, and thank you very much for having me, and nice to see all of you, and it's very good to have this opportunity. It's a new experience for me, so very excited about that. So quickly, I'm an associate professor of computer science at Brunel University, London, and my background is software engineering. I graduated from the University of Pisa in Italy. I'm Italian, actually from Sardinia, so it's an island, and we are very proud of our island. And I studied computer science all my life, since even in high school. Then graduated computer science engineering. Then I did my PhD in software engineering, so quite a consistent career. And at the beginning, I studied software engineering and classical principle software engineering, and focused on open source software and all the property of open source coding, improving the quality of coding. Then I shifted a little bit on studying how developers create this code, since I wasn't alive in open source community. And then I started, that was in 2015, 2016, I got interested in blockchain technologies in general, from the point of view of the software engineering aspects. And then you will see today in our first discussion, blockchain and in general, decentralized applications, smart contracts, are a complex system. A software, if we start looking at the software, simple program, software is a complex system. A complex system made of complex system, made by complex system, because the team of developers developing a software is as well a complex system. So we have this complex system linked to each other, and studying the properties of this system is extremely interesting for gaining different perspectives and understanding what's happening and improving things which can be improved during the development process. So for developers, for the software, and for the final users as well. So quickly, this is my background. I want to give you the opportunity also to join the conversation. So if you have additional questions, feel free to ask, but hopefully I quickly gave you an idea.
Cool. Thanks, Giuseppe. Now let's pick the first person who would be open to introduce. Sunny, would you like to introduce yourself? Hello.
Hey Angela, hey everyone. I'm Sunny. It's very nice to meet you. I mean, I've seen you in numerous different programs and lectures, and I just want to thank you in advance. Like, it's been really helpful in the academy. So a little bit of background on me. I'm actually involved in startup communities, and actually I'm based in US. So it's in the morning here. So I am involved in one of the startup. It's called CIF. That's based on AI and combined with the blockchain. And so we are one of our think tank research head is actually from Germany. So it is pretty interesting and pretty small world. So I'm involved in that space as well. So there's where I needed more token engineering because its impact is so great. So I wanted to know in depth. So that's how I involved in the academy. And on top of that, I also doing another startup that's actually involved in real asset tokenization with heavily in US focus, but the rental system and whatnot. So I'm trying to innovate in that space as well. So yeah, a little bit of background of me. And then I usually be in the Web2 space and I'm transitioning to Web3. So before that I was involved in quant side of investment side. So I'm a little bit of a lot of things in combination.
Okay, thank you so much, Sunny.
Welcome.
Great to have you on board. Good. Pedro, would you like to go next with a brief introduction?
Yeah, sure. My name is Pedro. Can you hear me?
Yeah.
Yeah. I live in Brazil, and for 8 years I've been working in traditional finance. I've worked with private equity. For the last 3 years, I've been working with private credit, but since college, my passion has been coding and game theory, but the environment here in Brazil for Web3 and blockchain just in the last 1 year started developing more. So I've been like training myself on the side. And now I'm trying to make a full turn to Web3 and work with DeFi, and also like the program here in the study sessions and also the courses have been a godsend because it's the perfect match for me because I love game theory and programming and blockchain. So tokenomics is like a godsend for me, and it's quite impressive the people we are having contact with. So thank you for providing me.
Awesome. Thank you so much, Pedro. Let's take a look who's here. Srikant, would you like to introduce yourself as well? Switch on your mic and your camera if you like.
Hi.
Hello.
Hi.
We can hear you.
Yeah. Hi, Giuseppe. Hi, sorry. Hi, Giuseppe. Hi. Thank you so much.
Angela.
Oh yeah.
Sorry.
Sorry. I'm sorry. Yeah. Yeah. I'm actually a working consultant in the Web2 domain of infrastructure area. Mostly, you can call me in the area of DevOps. However, I'm doing my distance masters in blockchain from University of Nicosia. And yes, tokenomics has been a very key element in my what do you say, in my personal interest, despite the professional interest, because professionally I would like to delve more deeper into the backend of the blockchain, unlike the NFTs and tokenomics of the blockchain. However, personally, as a uh, you know, as a person of understanding the social value of blockchain, I would like to understand how to leverage tokenomics in building a better socioeconomic system, especially when it comes to the DAO of making multiple universities and trying to democratize the uh, knowledge and skills accessible to across multiple countries. So it's more of my interest is more into DAOs and building tokenomics around DAOs.
Mhm.
And how do I do that, and how to help these people who are in it. This is the idea. Yeah.
Right. And I guess we can already say, even though DAOs are so early stage, that the system, the token systems we design here, not only the software systems, particularly the token systems and the incentive mechanisms here are, let's say, complex systems in its nature, and with additional challenges on the human side. So I guess you can learn a lot and gain a lot in this live track. And it'll be exciting.
Great. Thank you so much.
Thanks. Next student. Now I have to concentrate. Ailutea.
Alicia.
Hello, Alicia.
Hiya.
Okay. Thank you.
It's a made-up name. It's not. My name is Moo.
Cool name, though.
Thanks.
Good.
So I don't know. So I don't really have a background in software engineering. I studied politics, philosophy, economics, but that was many years ago. I did do a coding bootcamp about 5 years ago. So my work background is in cooperatives, actually, pre-blockchain. I've moved into a blockchain project recently, and I'm interested in DAOs and tokenomics and how they can help us to create incentive mechanisms for decentralized systems. And we are exploring whether and how it would make sense to introduce a token into the decentralized commerce ecosystem that we are trying to create right now. And that's why I'm here.
Awesome. Where are you located, if I may ask?
I'm in London.
Okay, in London. Okay, I see. Thanks for the introduction. Great to have you here. Next one on stage, Nati. Hello. GM.
Yeah, sorry. I'm here. So hi, here again. I think I'm participating in every track I can. So I'm Narishi on social media, content creator, educator, and also part of Platzi educational platform, where we are training on technical skills and blockchain and Web3 on LATAM region for LATAM students. So I like Pedro being here representing also LATAM. I'm a chemist and worked for more than 20 years in the industry, and I started on blockchain and Web3 5 years ago. I'm one of the students for the first cohort from Token Engineering Academy with the 5 modules already approved. And I'm loving all this topic. I'm a real fan, and I'm committed to share all what we can in this matter within our Hispanic speakers. We need a lot of this. And as Pedro was saying, we have many opportunities, many protocols already launched in this region. A lot of founders are coming from LATAM countries, but we have a lot of opportunities and challenges in terms of improving the quality of what we are developing, being more robust, more tested, and also bringing more value to fix real needs. That's my commitment. That's what I want to do, and that's why I'm here to learn from you and make this happen and help teams or mentor teams to make this better. Thank you so much.
Awesome. Najiji, what a speech. Let's go. Great. Let's say two more. Zach, would you introduce yourself as well?
Hey everybody, I'm Zach Zukowski. I focus on tokenomics at Borderless Capital. So I help all of our portfolio companies design the utility of the token to incentivize behavior that helps grow networks and deliver value to token holders sustainably for the long term. And I have been doing a lot of studying on complex systems and control theory and different forms of governance and value accrual mechanisms for tokens. So great to know you guys and happy to be part of this.
Great, welcome, Zach. Thanks for the introduction. Let's see, Violeta.
Sorry, you caught me in the middle of eating. All right, yeah. So hello everyone, Violeta here. First of all, Giuseppe, thank you for contributing to this. Bon dia. I'm a huge fan of Portocero. So my background is also not software development. I've been working in a combination of digital marketing and then later on service and product development. I have dabbled a little bit in coding, so I've learned JavaScript and Python basic level, and I've dabbled with Solidity as well. The industry that I work in otherwise are travel, software as a service, and motorsports. So quite a diverse area. And I've only been engaging in this sphere for about 2 years, so it really I've wanted to expand on the knowledge that I already have. This is a lot more broad than what I've done in the past. Thank you.
Cool. Thanks so much. And now, hello to everybody else who haven't had the chance to introduce. Now I'd like to direct you to our Discord channel. So I guess all of you are hopefully already members of our Discord, the T Academy Discord. And here we dropped some more questions for you to get to know each other. It's also for finding each other. So some people already started responding on this question. Let's get to know each other. I have a background in, and please indicate with the tiny little animal who you are, so that we have a picture of who's in the room now in Zoom and generally on Discord. And for any other introductions, it's always nice to say some words. So if you have a moment after the session or so, just let us know. And yeah, just 1 or 2 lines about yourself. Okay. I think we are good to go, Giuseppe. The stage is yours. Let's kick off the session. Excited for your live track.
Thank you very much. I wanted quickly to say that the first lecture will be quite high level, so apologies for the experts on the field, but then we will build on in the next 3 ones. So I'll start sharing screen. Can you please let me know if you can see?
We can see it. All good.
Okay, so I will keep also the chat open, and please feel free. Let's do this. Let's try to make the session as interactive as possible, because otherwise, me speaking for an hour can be a bit boring. So feel free to like post questions, and let's try to make this as like interactive session as possible. So I will start with the title of this mini module, the dApp analysis and exploring the complex system-oriented approach. As I said at the beginning, I'm an associate professor of computer science, Brunel University of London. Is a very nice university in Uxbridge in London. And I'm also part and co-head of the London Smart Bridge Lab. You can find the website here and you can take a look at our activities. The other co-head is Dr. Silvia Bartolucci, a colleague from UCL. So there are 4 episodes that we are going to see in this module. The first one today is an introduction on complex systems and an introduction also to dApps. What is a dApp? How can we define a decentralized application? Then in the second one, we will move to more details on the complex system-oriented approach for analyzing decentralized application. In the third one, we start analyzing and we'll try to analyze a dApp from a different level of granularities, and it will be clear what this means probably after today as well. And in the fourth lecture, we will try to incorporate also these metrics. As I told you at the beginning, I'm an engineer, and we really love to measure in general anything. And measuring a software, however, it's not that easy, because software is intangible, we can't see it. But we try in our daily life to understand how we can measure even intangible things, because we need to help optimizing them. And this is why it's important to dedicate, in my opinion, a lecture to understanding a little bit the software metrics and what we can gain from these measures. Today we will go through an introduction to complex systems, as I said, high level. Then we will see the characteristics, and then we'll move to an overview of this decentralized application and the challenging that we have in understanding and analyzing the dApps. And we will try to see the motivation. Why are we using complex system theories to study the decentralized application? What is a complex system? I try to simplify as much as possible the definition, but we can see complex systems like a cross-disciplinary area. And you can see that in our lab. Smart Bridge is bringing together different academics and researchers from different fields. Because complex system is complex by definition, and different systems are, different fields are interconnected. It's this multidisciplinary area, and we have these systems with numerous components which are interacting in different ways, and these components are producing behaviors which is not possible to predict if we look at the single component. So this is the main definition, and let's try to understand deeper. Range of connected elements, more elements communicating together. So we have this network, and in this network, each point is unique. However, each point is linked to the others, and if we look at the network, we can see that there is diversities, and there are different behaviors and influences among these points that we have. However, a complex system is flexible. There is a structure, you can identify a structure, but at the same time, this structure is flexible. What does it mean? That the way that these points, these elements are linked together is not random, but there is a structure behind it. The system follow a specific structure and they are able to adapt. And important term that you have to consider is this stable. The system is stable and able to adapt. What does it mean able to adapt? That an instability can happen, but again, the system is able to react and adapt. So this type of system is able to handle changes, and which can happen when the system is living. Another aspect is the unexpected outcome. There are patterns or a possibility of having outcomes which you are not able to predict by looking at single parts. So if you focus your attention to one individual part, one element of the system, you can't predict what's going to happen. These unexpected outcomes are extremely interesting also for decentralized applications, because what I want to do is I want to convince you that a decentralized application is a complex system. Maybe you don't agree with me, and it would be nice to see if there is this type of debate. These systems can change and grow. So there is when there is a new challenge, the system can adapt and grow and change. Giorgio Parisi is an Italian physicist, and he got the Nobel Prize in 2021 because of his contribution to complex system. And I attended one lectio magistralis that Professor Parisi gave at King's College London last January, and he gave this definition from the Nobel Prize in complex system, and I wanted to use it and share with you all. So a complex system can stay in many different equilibrium states. A simple system may stay only in one or few equilibrium states. So one characteristic is this possibility of moving in different states of equilibrium. What is a state of equilibrium? A state of equilibrium is something stable. Again, the concept of stability is appearing again and again, and it's central. Think about an animal like a dog, which can do many different actions, like play, sleep, eat, hunt. So an animal is able to switch from one state to another state in a very short time at the effect of a small perturbation. So when there is a noise, for example, a dog immediately wakes up. What does not change over time is not complex, while a system that can take different forms of behavior is a complex one. I really like this definition because it gives you an idea of how many complex systems we have around. Even describing like the behavior of an animal can be defined as a complex system. There are many, many interesting papers of Professor Parisi and also many interesting academic papers, but he's a very good communicator as well. So there are many books which are quite accessible. What they did in Rome, this is very typical in Rome during the evening. We have I don't know if you have ever seen this flock of birds moving around. They can move and create this beautiful shapes which change very quickly. Sorry, Angela, do you have a question?
I mean, this statement beforehand on the slide beforehand about the complex systems and the many different equilibrium states, of course, for anyone in economics poses immediate reaction on. In economics, you always try to find equilibrium and keep equilibrium stable. Now, I mean, I know you're taking the software perspective. Is there anything you'd recommend to take a look at with complex systems, many equilibrium states versus economics trying to achieve one stable equilibrium to make economic systems less gameable and align incentives?
I'm not an expert in economics, so I can speak for the side that I'm used to in software engineering and in software. However, when there is an equilibrium state in a complex system, usually that equilibrium state stays for like sustainable, like quite a long period of time. For example, geological errors can be seen as a complex system. This is an example that Professor Parisi gave. And we have a stable, long period of time, then a sudden change, and again, stable period of time. So there are different stable states, but we have disruptions, if I can say so, but which bring to another system, to another stable phase. From the, of course, the economic example really fits the definition of complex system, and financial markets are, by definition, a complex system. There are different elements and different outcomes. Your question was related to, is it good to look at only one equilibrium state?
I would rather, it just raised some question marks that I want to further explore. So, because of course, equilibrium can change over time, no doubt. With looking through the complex systems, I wonder what are the key new properties we have to keep in mind when it comes to equilibrium states. I guess this is my question, and I assume following along will help me understand.
Okay, but again, in software, there are many elements moving this different state. I will try to summarize those different states that we have. Mm-hmm. So in this picture, like I was saying, in Rome, they started, and the team where Professor Parisi was, they started studying how this flock of birds move and how they behave. And if you try to study one single bird, like for example, one that we have outside of the flock, that bird doesn't know anything of what's going on at the other side of the flock. So what they discovered is that one bird is knowing only what's going on with the neighbors. And however, the system moves in a very specific way, and the flock is moving together. So all those behaviors, which are very well structured and well defined, are the outcome of like we couldn't predict those shapes that we can see only studying the individual bird that we have. Another example of complex system is the human brain. There are all the neurons which are linked together, and we have emergent properties, the learning, the emotions, and so on, and the dynamics of the patterns of the activity in our brain, and the adaptability, the learning experience, and the response to stimuli. Biological systems, again, the different species interacting, the properties which are emerging when the species interact, so the resilience and the nutrient cycle, like think about a forest, the interplay that you have within a forest. Social systems. So as you can see, different fields are coming in here. Social systems, when we have an interplay of infrastructure, so transport, the interactions, and all the economic activities. Think about New York City. If you look at New York City from outside and you check what's going on, there is like kind of equilibrium state. If everything works, public transport is working, then all the taxis move around, all the people. So it's it's structured with all the different elements there, and there is self-organization. This is very typical also in open source development. All the teams of developer working together for creating the output, and also the social aspects here come into play. Sorry, let me check the questions as well. I believe there is an agreement that the whole is greater than the sum of its part. Absolutely, yes, totally agree. One element that we will see, one characteristic of complex system is that they are not linear at all. So absolutely, very good point. Financial markets are complex systems as well. We have this network of financial institutions, the investors, the assets, and then all the different properties of a financial market. We can have crashes, and then the system adapts again to these events, and the dynamics are definitely non-linear. Again, we have feedback loops. Are you aware of what's a feedback loop? Jump in the conversation if can you type in the chat, yes or no? Okay, so there is feedback loop in a complex system is important. I will go into details maybe a little bit later. And adaptive behavior again in the when there is a change, when there is a changing condition. The internet is another very complex system, computer and devices. Think about how the internet has changed over time. It started like with sending an email, and then the evolution of the internet. Today, everything, the Internet of Things, and all the devices basically connected. We have washing machines, dishwashers, connected to the internet, and the different possibility that the internet gave us. Information flows, the routing, data transmission protocols, and the network, the way that the network is created, and the way that the network also survives. So why it is important studying this complex network, and why we are using also complex networks for understanding decentralized application, the behavior of smart contracts. It's important because we can understand and we can predict emergent behaviors. What is an emergent behavior in a blockchain technology? Any idea? Can you give me an example of a behavior that we can have and it would be nice to predict? The first come to your mind. Come on, don't be shy. Angela?
No, I was just wondering, type in the chat.
Yeah, or type in the chat, or feel free to. We are a good number, so I think that also jumping in the conversation is fine.
About inflation in the US dollar or spending in the economy?
Sorry, can you repeat?
It would be nice to predict what like inflation in currencies or spending in the economy or like GDP would be.
Yeah, well, like the question is related to what is a behavior that you would like to be able to predict, and can be an emerging behavior in a blockchain system. Let's consider, for example, Bitcoin. If there is a fork in the community, for example. How you are able, you are providing very good answer, by the way. They are very specific. I was thinking more like a more generic one, but think about the possibility of forking the system, moving from it happened Bitcoin Cash, or the other types of events that you can have. And how this forking can happen. If there is disagreement in the community, for example, if there is disagreement in the community and we have like a fork, would it be interesting to predict that fork? It will be, because actually a fork can have an impact also on the value. I can see now there are comments about the value of the currency. So even predicting, like in a very simple way, predicting the value of the currency will be very nice. So understanding all this complex system, understanding the behavior could be helpful. And as I said, emerging behaviors arise from the interaction of the components. Let's go back, for example, to the forking. If there is a disagreement in the community and there is a forking of the blockchain or the community, predicting that forking can be quite interesting as well. Studying these complex networks that we derive can help in identifying all these mechanisms that can drive these different behaviors. And if we are able to identify and to study empirically what happened when we had forking in a specific platform, for example, looking at how developers were discussing before the forking and predicting what was happening, in order to understand if we can predict that happening again, that can be quite interesting. Also, understanding and studying complex system is going to enable the development of predicting models. Predicting models are quite important in every field. So you can anticipate potential risks or consequences, that like mitigating, preparing, for example, developers if something's happening with the system, or think about the when there was switch from proof of work, proof of stake in Ethereum, trying to understand how developers can work. And all these aspects can be helpful when there is the possibility of understanding emergent behavior, which is not possible to like, otherwise you have to see empirically what happens. If you understand the complex systems, we can design more resilient and adaptive solutions. We can incorporate feedback loops, and we can enable also self-organization and distributed control. An effective management requires the monitoring and the responding of the system in real time, promoting, of course, collaboration and adapting continuously to change. Now, properties. We give specific technical name to the properties that we have. These systems, as I told you, are connected. So these numerous components are interconnected, interact with each other. Think about the flock of birds. There are no wires, but like one bird is aware of the neighbors. So that's, we can see as a social link there. And in this case, is an informational link, because the link can be physical. Think about another complex system is a flight simulator. A flight simulator is extremely complicated. There are different components linked together. In that case, we can have functional and also physical connection, the sound, the image, the throttle, which everything is simulated there. And we can have different type of connection in our system. In social networks, we have an interconnection which is like social. So we have relationship among people, for example. Diversity of components, they have different characteristics and behaviors, and this is helping the robustness and the adaptability, and like the example of the ecosystems. The adaptability, so they adapt to the changes that we have. Emergent behavior we defined earlier. Non-linearity, I want to stress the non-linearity part, because we have a cause and effect and a linear relationship between cause and effect. Butterfly effect, small change when there is an initial condition can lead to large effects later. Dynamic nature, evolving always, and they shift when the behavior shifts when the interaction among the component changes. Think about the cities. Feedback loops, which are complex. We can have two types of feedback loops. One is negative. A negative feedback loop stabilizes the system. Human body, there is high temperature. Paracetamol stabilize and bring the temperature down. So you help to stabilize the system. Positive feedback loop amplifies the effect. So a positive feedback loop is amplifying what's happening. Social media, you start with a social media, it becomes popular. The more popular, more people subscribe, and the social media platform keeps growing. That's a positive feedback loop, okay? Now, let's move to software. And I always start with comparing, trying to explain why a software is a complex system, and we set the stage for understanding why a decentralized application is as well. Questions so far? Silence, I take as a no. Okay. So I know many of you are not developers. Java is a very popular programming language. There is no need to be a developer here for understanding what I want to say, but I want to give you a couple of information about a software system. A software system is, think about word processor. That's a software system. And the word processor is written in a programming language, which can be Java. Java is a high-level programming language, still very popular and quite used. How does Java work? In Java, you can define these different elements that you link together, and these elements are called classes. So, for example, let's think about the word processor. Again, all the menus and the icons that you have are a specific class in the system. Every class, each class in this Java system has properties and behaviors. It's like a part of the system helping you in doing something. Think about the human body, and the liver is one class, the heart is another class, lungs are like another class, and these are all connected together, and they do a very specific job. So these classes are linked, okay? We can actually visualize the system in a specific way. And if we think about each class linked to another class, we obtain a network where each class is a node of our network. Network can be also, I'll give you another example. Imagine different cities linked by roads, okay? So a class, again, is the city, and the link between the cities, like the road. A class by itself can do anything. It's the software, the behavior of the software appears when all these classes are working together. So if you look at the Java system built as a complex network, you can try to understand if, for example, a class is linked more than others. It's called a hub. For example, London in the UK is an app. It's linked to many, many, many other villages and other cities. And if something, there are airports there. If something happens there, there will be an impact to the country. Okay, that's, I don't know if you are getting where I'm going here. So understanding the network that it's behind the software in this case can help developers and managers to understand what happens if a class is targeted. Think about cybersecurity, for example. If an hacker wants to attack a specific part of a software and the hacker is able to identify the hub, which is the most important class in the system, then it's easy to destabilize the system as well. So why it's important to see this network? Because if I'm a developer, I can understand the principle here. Do not give many responsibilities to a single class, which is a very important principle in software engineering. You have to avoid the so-called God classes, like do not have a class which is doing everything, because if I kill that class, the system will crash. So you delegate responsibility to many components of the system. Look at this image. This is Tomcat. It's called. It's a Java system. I collected all the classes of the system, and I built a network. Each node of you can see here, each point is a class. And if a point is linked to another point, it means that those two classes are linked. What does it mean linked? It means that maybe class A is calling class B. So there is class A, which is saying, class B, I need this piece of information. And class B can send that information. So it's a functional link in this case. And then there is, if you notice here, there is a red part of the graph. Can anyone guess what the red part is? It's a difficult question, this one. But can anyone guess why I have a red part here? Same principle as for risk management, distributed impact in many factors. Yes, absolutely, Nati. That's a great parallelism. So can you guess why there is a red part in the graph? Red is like alerting something. Relationship map. I was trying to map the relationships among classes here. But I wanted to show you there is a specific area of the network which is red. So those red points, nodes of special vulnerability, that's very close to what I'm going to say. Zaremba, thank you very much. Those are buggy classes. What does it mean? That those classes have at least one bug. So it's possible to understand, if you look, if you are not familiar with open source software development, there are repositories like, you are probably familiar with GitHub. On GitHub, you can find all the information related to the development of a software which is hosted on GitHub. And you can have access to everything, basically. The code, the commits. A commit is when a developer writes a piece of code and then put the code on GitHub. Let's simplify in this way. And then there can be a bug in that code. Bugs are a characteristic of software. We don't have a software without a bug. It doesn't exist because, as I told you at the beginning, writing software is extremely difficult. It's a complicated activity. We don't see software, we are writing code, and errors, faults, bugs, first of all, are in the human nature. And if we don't have bugs in a software, it means that no one is using that software. So bugs are part of our development process. And we try to mitigate them. And using complex network is an approach for mitigate them. So the red part here is indicating buggy classes. So here I was able to understand, because you can tell from GitHub if a class was buggy because developers start fixing it, so you can understand. And if a class contains a bug and it is linked with another one, it can be problematic for the other one. So there is a question. A fork is a new class and connection in this chart, for example. No, Nati, no, a fork is a deviation. So, for example, you have a fork of a system. If someone else decides to use your system as a baseline, but deviates and creates other functionalities. So a class in Java is a functional unit. It's a piece of code which is doing a specific action. So in this case, forking is not here. No, it's not in this image. This image is just a picture of the system in showing the links that we have among these classes, and showing you how buggy classes are linked. My idea at the time when I built this graph was trying to answer a question, and it was, can I predict if a bug is contagious? Like, think about spread of bugs in this network, which can be the spread of a virus in a population, for example. You can do this parallelism, for example. A bug in a smart contract is called vulnerabilities. So if you see this network as a network of smart contracts, for example, you can see the red dots as vulnerable smart contracts. And if there is a vulnerable smart contract, we need to pay attention to what's happening here. Can I move on? Do you have questions about this? Why are classes that are isolated and close to each other? Very good question. Thank you very much for this. Sometimes in a system, you can see there are classes they are called self-loop. So classes which are calling themselves, basically. Those are self-loop because a class has specific properties and the class is able to call functions of itself. In this case, there are isolated classes because I was going to check here only direct link. This is a very good question and very technical. The type of relationship that you can have in a network are different. So a direct link between class A and class B exists if class A calls directly class B. However, there are a possibility of having links in the class, like, for example, indirect links, which are not represented here. So this representation, when we have isolated class, doesn't mean that those classes are not collaborating with others, but only that I was looking at one specific picture here, one specific behavior. And this is quite important because I can have different pictures of the network from different perspectives. And without the complex system approach, it wouldn't be possible to have these different aspects and all these different possibilities here. So I hope that I'm being able to show you the importance of applying these different complex systems comes from physics, and we are using software engineering here, but understanding the weakest part of the system can help improving the stability of the software in like with a very high degree, with like it gives a completely different view to the developers. Okay. So I think now you have an idea of why a decentralized application can be seen as a complex system. These decentralized applications are software running on a blockchain. Again, I want to simplify as much as possible. Think a blockchain as an empty, like this phone, you don't have anything here. It's black, but you can build an application on top of this phone. And if you build an application here, you are able to do something. So see the blockchain as an operating system. Allow me to simplify. I'm simplifying as much as possible. It's not exactly like that, but we can see the blockchain as a backbone. So where do I install my application? On a blockchain. So I can see and think about the blockchain as an operating system. My decentralized application runs on a blockchain. But you know that a blockchain is distributed. There are all these nodes communicating together. The mining process, consensus algorithm, complicated. So let's imagine blockchain, an operating system. I can install a decentralized application there. Again, installing a decentralized application on blockchain comes with all the pairs that we have. So everything is stored. I can't go back, and you know how a blockchain works. These dApps are decentralized by nature, all those nodes that we have on a blockchain. And the main blockchain used for dApps is Ethereum. There are many more, but the main one is Ethereum's. And the core part are these smart contracts. I started telling you about Java classes because I wanted to do this parallelism. You can see, if you remember the graph, the network with the classes. Think about a class like a smart contract. Again, I'm simplifying a lot here. It's not exactly like that, but it gives you the idea. dApps are made of smart contracts which are collaborating together. So one smart contract is able to call another one, the smart contract another one, and so on. And then we have this network emerging here. They are open source. Open source means that the code is available, and you can look at the code, you can check the smart contracts, and you can understand what's going on. And they are used for many purposes: financial services, games, social media, and marketplaces, for example. How many of you know Uniswap? Feel free to type yes or no, or very good. So you know you are aware of Uniswap as a decentralized application. You can install Uniswap on your mobile phone, for example. And let's consider a simple example. I will describe this Uniswap Lite. I simplify this the concept that we have in Uniswap, and I'll try to describe a very simple dApp, which is Uniswap Lite. There are several components. The automated market making. So this platform removes the need for the traditional markets matchmakers. And the core of this automated market making are the liquidity pools, okay? So you can have this continuous trading, and there is no man in the middle, okay? So there are liquidity pools, the automated market making, and there are no intermediaries in the middle. Liquidity pools are the reserves of two types of assets. For example, you can have Ethereum and the stablecoin. And user can contribute to the pools, and they can be basically the liquidity providers. There are, of course, the transaction fees as a reward, and there are incentives for maintaining the liquidity pool. Direct trading and the dynamic pricing. So the users are trading directly with the liquidity pools. There are no order books, but you have formula which is based on the ratios of the assets in the pool. The centralized operations. So you have the blockchain technology here, like think about Ethereum, and there is no central authority. So all the users have full control. So here we have our simplified Uniswap-like decentralized application, and we have the automated market making, liquidity pools, trading and pricing, decentralizations. All these elements here, if you remember all the definitions that I gave at the beginning, make like a complex system. 100% we can match all the properties that I told you at the beginning. The liquidity pools are representing a network of interconnected parts, okay? So each pool is linked to the other, and we have all these different components, the diversity here, because each liquidity pool is operating under a specific set of rules, and depending on the trading volume, the user provided liquidity. So the diversity of components here is clear. Is this Uniswap like the centralized application? Are we matching the definition of adaptability? Well, there is a very high degree of adaptability here, because think about the trade shifts that we can have, and the like the market sentiment. So the provider, the liquidity providers here can enter and exit, and the traders can execute the trading at any time. Emergent behaviors. Think about the pricing mechanism that we have. Again, there is no single participant dictating like a price, but again, collective action of traders. No linearity, because all the relationships are non-linear, and large trades can lead to price impacts, and again, they can trigger the cascading effect that we can have. Dynamic nature, the system can rapidly transition between the different states in response to a perturbation, and like we can have like a shift in the market, which is altering a pool, for example, and feedback loop. Governance models can introduce here complex feedback loops into the systems and can change the parameters. So at high level, if I go back 1 second here, I'm only describing here the functionality of the dApp. Okay, I'm not mentioning the technical and the architecture part. I'm not mentioning the smart contracts, the point of the network that you saw before with the Java system, but only describing the application. You can tell that this matches all the definition that we provided for a complex system. Let's move a little bit deeper here. I promise this is the last step, and I know that I'm telling you plenty of information today, but then in the next lecture, we will break down all the elements. So today I'm throwing you all these definitions and different views, but we will be breaking down all the concepts during the next 3 lectures. Today was an introduction of all the different aspects, and I'm trying to link many things. I know this, and I apologize, but hopefully everything will become like clear. So I'm moving from higher level of granularity, looking at how the centralized application is working, and then I go deeper now into the architecture, and I want to check the smart contracts which are in the decentralized application. Again, keep in mind that this is a simplified version of the Uniswap app. We have a factory contract, and this factory contract is responsible for creating new smart contracts for each pair of cryptocurrencies that I have, okay? So it's this factory contract is able to deploy an exchange contract when it's a new market pair is needed. Then I have an exchange contract, which is dedicated to handle all the trades and the liquidity for token pairs, and they use the automated market making. Then I have the router contract, which bridges all the user with exchange contracts, and liquidity pool tokens contracts. I'm telling you all the technical elements now that I need to code to make my app work. The liquidity pool tokens contract is going to issue the tokens to user who provide liquidity. Then another contract responsible for the governance, which facilitates the governance systems. And then the wrapped Ethereum contract, because when we need to trade Ethereum in a tokenized form, we need to wrap the Ethereum to wrap Ethereum using the ERC20 tokens. Then other contracts again. When I'm saying other contracts here, I'm meaning all the developers, like here, sitting down and writing all of them. All the developers writing each contract that I mentioned. Staking contract, time lock contract, migration, position manager. We will see this into details. What I want to tell you is that here, if I link all these contracts together, I get a network like this one, which is related to the original Java network that I presented. Think about each point a class, in this case, each point a contract. These contracts are linked together, and they are performing some operation. For example, the governance contract affects the router one, which is interacting with the wrapped Ethereum contracts, interacting with the exchange pool. So even this one is a complex network. It's a complex network with dApp describing the functionalities, but if I go deeper, I code each contract, I build a new complex systems, which is made of all the different contracts which will work together to make my app like functional, okay? So all the different contracts here are linked together, and this is a complex network. Again, not the functional like describing the dApp, all the characteristics that I told you, but also from the point of view of the coding. Now, here there are all technical names like the router contract linked with the wrapped Ethereum contract for wrapping and unwrapping, factory contract, task with creating new exchange pools, contract, and so on. And then we have all the external dependencies, because all these contracts are related to our dApp, but then these contracts can call contracts which are defined in other decentralized applications. So things can get even more complicated, and these are the external dependencies that we have. There is a question: how can you represent vulnerability to rug pull with this similar network? That's a very good question. So we will cover this part about vulnerabilities in the next lectures. Actually, what we are trying to do in our lab is trying to predict vulnerabilities. How? Understanding the, look at this graph here. Forget about the functionalities. They don't matter at this stage. We don't know anything about the functionalities of the contracts that we have, but we look only at the structure. We can even delete the names of the contract. And we try to understand if there is a box, in this case, which is linked to many others. That's the first time. We don't know anything about coding. We don't know anything about anything else. We just look at the number of arrows going to that box. If there are many of them, that's an app, and we need to tell the developers, be careful with this one because everything is linked, basically. And if there is an attack to this contract, your decentralized application is not going to work. So if you look at the structural pattern only, without knowing anything, we don't know anything about coding. We don't know anything about possible vulnerabilities in the code. There are, but we don't know here. Only looking at the structure of the network is a first hint and helps in understanding how I can improve the structure. And only looking at the architectural aspects. So I look at the shape, basically, and say, this one, it's an app. Be very careful here. It's like having a control room where you can see the decentralized application from a different perspective, and you can like tell developers that maybe are working in isolation and don't have a complete view what's happening, because sometimes this can happen. Representing vulnerabilities is complicated. First of all, my question would be, what type of vulnerabilities? Because we have different type of vulnerabilities. Structural, the one that I told you, but then other vulnerabilities within the code. I know that many of you are not developers, but in software development, we have loops, meaning that you have an operation which is performed many times under center condition. Very often, we can find an infinite loop. Infinite loop is our enemy, because an infinite loop will crash your system, basically. So what you have to do is to avoid infinite loop as much as possible. That's why we have gas system in Ethereum, by the way. Not only because of that, but that's one of the reasons. But you know how difficult it is to check if the condition that you have in the loop is correct or not. Because maybe statically it's correct, dynamically you don't know till when the system runs. So predicting vulnerability can be extremely complicated. So understanding what type of vulnerability here is the first important part. And then adding another picture, another view, another level to understanding this type of vulnerability is helpful for building a better system. Because like the optimal system, it's very difficult to reaching an optimal stage in software development is complicated. So we can keep improving our system, but building the optimal one is from scratch is extremely difficult. Let me go to the last 2 slides, and then we can open the stage for questions. In this paper, which I will share with you, I describe the approach that I started telling you today in a high-level form. So I will share this paper with you. And you can find the slides available. And I will give you the complex system papers, another one, so you can read it. And if you want, you can summarize and reflect on the discussion that we have today, and write down why you think a complex system relates to a decentralized application. So this is for like giving you for the thoughts for the next session. Now, really, I would like to hear from you and try to answer your questions. Let me also stop sharing so we can.
To what extent do you use visual representations of systems in your research? Because I feel, how to tackle complexities when it comes to, from how to tackle the design process or the analytical process, actually.
So visual representation is gives you a first understanding of what's happening. Then there are techniques in complex networks that you use to understand what's going on. If the network is extremely large, then the visualization is not helpful because the network will be incredibly messy. But you can perform cluster analysis, so you understand more or less how big are the different clusters that you have in the network, the degree distribution. So there are many metrics which can be helpful for understanding the structure of the network that you are dealing with. And there are well-known patterns in networks as well. And you can see if the network you are analyzing matches mathematically those patterns. And since there are many studies conducted in all those different patterns, you can apply all the different aspects already studied in those different patterns that you can obtain. So visualization is one aspect, and it can help at the beginning. Then you apply all the different processes, and you process the network to understand like what you are dealing with. I'll pick a question from the chat. Is it okay?
Feel free to pick them up. There are several questions in the chat, and some people raised their hands.
So in your knowledge, what is one of the best ways to mitigate vulnerabilities by controlling in real time? This is a very difficult one. Thank you very much for asking. My knowledge to mitigate vulnerability in real time, my knowledge is very limited because it's very difficult to mitigate in real time. What we are doing at the moment, in real time, basically, you look at what's happening and you try to mitigate what's going on. But that's not the best approach. If you think at the beginning when smart contracts started operating, all the vulnerabilities emerging, it was a new field, and it was we started learning from the experience. Problem in the systems, we try to fix it. What we are trying to do in our lab and with my research with my colleagues is try to give all the tools and ingredients to the developers in order to avoid vulnerability in real times. If we find vulnerability in real time, we are already late. So what we are trying to do is, can we prevent vulnerabilities from happening? So can we predict vulnerabilities in the code while writing? It's an open field. It's complex, as complex systems. And there is no a single answer. And we are bringing also in like in software engineering, there are years and years of studies related to bug prediction. You have classes, you have information. Can we predict a bug? Yes and no. Sometimes we can, but again, I simplify again here, but I think it gives you an idea. Can we predict a virus in where we have not been able to predict the pandemic, for example? So similar in software, we can predict bugs that we know maybe, but what if we have a new one? And again, real time, we should not get there. We should try to predict before, because real time, it becomes even more complicated and more difficult. I hope I answered. Well, I answered basically not knowing how to predict in real time, but because in real time, we are a little bit late. Sorry, how will this connection for a launch project are monitored in real time to discover vulnerabilities? Are people in the project specifically dedicated to control or metrics? That depends. Depends on the team of developers. Depends on how the people are working in that specific environment. There is no one answer for all the projects. It really depends on. Even like if there is a company developing a decentralized application or a system, depends on the policy that the company has. There is no one answer here, I'm afraid.
I just realized we should read out the questions so that people can follow who don't see the chat, but totally fine. Let's call up Saremba now with her question.
Apologies.
I think I'm still processing quite a few things that you said, so my question will be probably characteristically for me complicated and multifaceted. But I'm wondering, in theory, at some point, this type of analysis might be used for a team to be able to choose, let's say, L1 and L2 for their dApp. Let's say that this team thinks that the type of risks that they are mostly worried about, I don't know, it would be like spillover risk. I'm sort of taking the spillover risk more from sort of financial networks, but maybe let's say that they would define that there are several types of risks that they are more worried about, and with this choose the network that seems to be mostly robust to that risk. Is this sort of the idea? Or is this too far ahead?
It depends. So adapting the software development. So this is a very good idea. If we could do that, like understand which network is the best, like network configuration is the best, and then do kind of reverse engineering for developing that, following that pattern, that would be great. But this is extremely difficult, and it will be an ideal world and bring it together physicists and software developers, which is not going to happen, in my opinion, very soon. But understanding that would be extremely helpful if we could be able to present patterns which are better suited for a specific type of decentralized application. That would be great. That would be like a valuable piece of information. So a team would know, okay, if we are building this and we know from empirical evidence that this specific pattern in a network is better, then we start developing that way. That could be a great result. We are not there yet, but definitely it's a perspective. We can't force. I was a software development. I was a software developer before going back to academia. Still write code for my research. I can't say that I'm a software developer now, but following a specific pattern coming from a network perspective would be extremely difficult for a team of developers. Remember that there are different layers. Also, a team of developers is another system by itself. So there are emerging behaviors also there. And telling a teams, okay, you have to use this network framework for building your code, it will be almost impossible.
I guess I'm coming from the idea of like more from analyzing complex systems like in different places rather than here. But I imagine so like there are some patterns or some characteristics of the systems that are maybe better, and I guess even without having all of the analysis, because that's way too complicated, you might still maybe have some sort of characteristics that are useful enough to say that, for example, it's better to build something on Ethereum because, I don't know, just because of the popularity, and some of that can be expressed in terms of network properties. But maybe if the gas costs are more important than the fact that this is such a big interconnected network, then so I'm just thinking that still you might have some properties of the system that are useful enough when comparing the network. Or is it that you only look at the dApps on Ethereum and not really on any other networks?
No. We are looking at different networks, also different languages. Not only on Ethereum. We started analyzing on Ethereum, but we are expanding. So it's there are many elements, as you said. It's also here operational research is coming into play, because it depends also on the type of infrastructure that you're using, what you want to optimize, so from our perspective, we are looking at the best way for building a decentralized application in order to minimize failures, like vulnerabilities, I would say. But definitely there are many perspectives that can be looked at and checked. You are also providing many insights for our research. So your questions are extremely valuable, and you are getting the point. So it's quite an open field, and many elements can be considered. Absolutely.
Thank you.
You're welcome.
Okay, let's take a look at the chat again. Violeta commented, we could predict predict probability of bugs, but not black swans, I think. Would you agree?
Yeah, we can. But again, even predicting probability of bugs, of known bugs, is a difficult task. So yes, there are many attempts and many good methodologies for bug predictions. But again, in traditional software, there are elements which are different if we look at the centralized applications, for example. The centralized applications are running in a decentralized environment, in a distributed environment, and with all the new characteristics that we have with a blockchain. Blockchain is a relatively new concept. So when there is a new concept, a new infrastructure, we still need to experiment, and we need empirical evidence of what's happening. So even predicting new vulnerabilities, it's not easy. It's a very difficult.
Maybe for those who don't know, clarify black swans. I mean, it's improbable events, right?
It can be an improbable event, or in my field, for example, an event which was not known before. So we can classify a black swan also something which is not in the literature. For example, we can classify all the type of bugs, but then there is something that we missed, and which happens, and we didn't predict that one. We didn't even classify that one. That happens in bug prediction quite a lot.
Cool. Victor added another question, and maybe we don't have to go over fully software engineering fundamental knowledge, but he asked, what is the difference between a class and a node? I mean, when it comes to analyzing complex systems, probably.
In our representation, the representation that I presented earlier, there is no difference. A node is a class. It's just a way of representing a class. So node and class in that picture with all the different dots linked together, nodes and class are the same thing. A node is a way for representing a class.
Okay, thumbs up from Victor. This was helpful. And Said asked how one can simulate a complex system operation with mass users. What are the tools and methods for that?
At the moment, a way for simulating is using agents. And using agents for simulating a complex system can be helpful. However, a simulation is a simulation, which means that it's extremely limited in showing also emergent behaviors, because you usually simulate aspects which are known. Okay, so getting information from a simulation can be helpful, but again, if we want to understand and we want to predict new vulnerabilities, simulation is not the best tool, in my opinion. But definitely, they are extremely helpful. And agents are a perfect tool. Also, now we have new field with AI tools emerging basically every day, and also these new tools can be very helpful for simulation purposes. Think about agents built with the support of large language models. Large language models, they are called generative AI. We can debate about the word generative here, but definitely these tools have they have large data sets, so the knowledge of these tools can be quite important, and using agents based on large language model can be helpful here in simulating, helping like the simulation aspects. You're welcome.
Any other questions? Thumbs up from Said. Okay. If we don't have any other questions, Giuseppe, could you pull up the homework again? And one
Yes.
question, can we access the slides? Yes, we'll share them on the Notion
Absolutely.
Information Hub details page about the Live Track 7. Okay, I wonder, now coming up with a proposal when it comes to the NFT, Giuseppe, could we make this count, like collecting points or so, for acquiring the final NFT proof of knowledge?
Why not? Yeah.
So
I
we'll think in the background, and then everybody can already start accumulating achievements to acquire and earn the NFT at the end, and we'll share more details. I think this could be just a nice contributions to have the not online exam only.
I agree. Yes. Maybe we can discuss better the details, Angela, together and get back to this.
Good. Any questions? Victor, okay, Victor raised his hand.
Just very quickly, can you hear me?
Yeah.
It's kind of more a personal curiosity. So when you look at from an academic perspective, but also with a software engineering background, when you look at the history of software engineering, and you see now basically a lot of these smart contracts are obviously publicly available. You can go through the code and have a look at it. And would you say that, like, personally, what is your opinion, like historically, particularly thinking about IP issues in the past, when you have closed systems, when nobody has access, is that like now easier? Would you say that things go much faster and is much more collaborative, as one would assume? Or would you say there are actually a lot of other issues that people don't realize? And if yes, then can you mention some? And like, just can you give a little bit of a maybe historic overview how this developed in the last couple of years since blockchain became a thing? I would be interested.
I have to say that, in my opinion, this is completely a personal opinion. Open source software has been a big thing for understanding software development and for improving software. Having the possibility of studying the code written by different developers in different countries with different background helped immensely like the subject, the field. We started improving also all the techniques when we started having access to all these data. And software engineering is still quite young. So the subject is young, blockchain is even younger. Blockchain is basically a kid, 2009. Software engineering as a discipline is 60 years, more or less. It's 60. And so having the possibility of accessing the code is key, is probably one of the most important aspects in software engineering, even because you have a complete view of what's happening. And one thing that at the beginning wasn't considered was the human factor. One field of my research is human aspects of software engineering, because they are fundamental. Not looking at the human aspects of software developers was a big mistake for years. Now, the importance of the developer and the background, the differences, the diversity. There are studies showing that if you build a diverse team, that team will work better. Because different people with different background, different cultural aspects, different languages bring different perspectives. But this wasn't easy to understand without data. So the fact that many blockchain systems are by default open is a big plus, because you can check from the very beginning what happened, and you have you can even go back and rebuild basically everything here. So we are definitely better positioned in understanding what's happening, predicting behaviors as well, than when we were analyzing traditional software, if I can say so. At the beginning, software was built by companies. They were disconnected. They were writing code. No one could access those code, those software, and there was limited understanding. Think about the change we had with the internet, and then when open source paradigm started. Unix operating system, Linux, big competitor in jumping those barriers that you have when you want to enter a very specific market, like the operating system ones, where you can count the leaders in the market. But in if you look at the open source paradigm, and the fact that Linux is a competitor of big operating systems, it's a big result. And so from my perspective, having access to everything can help understanding better what's even predicting emerging behaviors, if I can say so.
Thanks.
You're welcome.
Zaremba dropped a final note. Would you like to comment yourself, Zaremba? Yeah.
The bigger a company, the bigger the legacy code. Absolutely.
Oh yes, like when years ago, I was working in a hedge fund, and just the horrors of legacy code, where there's something that is used and that has been written, for example, in one language, but the company is trying to move to a different language, but still occasionally you have this legacy code that is run because this is the one that everybody knows that it actually works, and people are a bit worried to touch it. Yeah, I guess the biggest weirdness of legacy code is probably NASA and a lot of situation there. But
what is proof of NASA?
Yeah.
I'm sorry?
What is proof of NASA?
No, I mean NASA, as in the I don't remember what's the shortcut from, but when they were sending
national
yes,
space agency.
Yes, that's
you mean the national space agency?
Yes.
Yeah.
Aha, okay, NASA. Okay. Mm-hmm.
Yeah, you still occasionally have I don't know, at least 10 years ago or 15 years ago, I know that they would buy the machines from, I don't know, 70s, and try to find coders who would be able to use the code from the machines from 70s, because change to a different system, even to a different type of computer was, although the upside of having such antiquated solutions was that it was much more difficult to
protect them,
to infiltrate it.
Yeah. Okay.
Actually, Margaret Hamilton is the woman who invented the field of software engineering with the Apollo program. She literally invented the subject, and yeah, the fact that the legacy system in that case worked better, it's also because it was more difficult to attack. So yeah, but I agree, the bigger the company, the bigger the headache. Totally fine. And Dimas, thank you very much for your comment as well. Glad that you enjoyed it.
Okay, there's two more comments. I read out Wen's comment, if I may. For trading infra build, yeah, so this was a comment on a legacy code. Legacy code are not written in a nice way. When successor programmers try to add it into a better version, it's often the case that they fix it with a nicer way, but prop a bug elsewhere, causing big monetary loss. Yeah, this danger, I guess.
There is a field of research on legacy code. Yeah, it's a big field. And actually, again, large language models will help here, in my opinion, because these models are very good at explaining code. And usually, when there is a new developer joining a software development team, the learning curve can be quite difficult. But think about the power of these large language models in helping explaining what the code is, like legacy code is doing, how quickly a software developer can become active in a team. So there are new things coming up.
Okay. Thanks so much for this first session, everyone. We'll collect all the materials, share the homework again in the Discord channel, and keep you posted. We'll meet again, keep in mind, next Monday already, with the next session with Giuseppe. And yeah, excited for the second round. Thank you so much for today, and see you on Discord, everyone.
Thank you very much. Have a nice weekend, everyone. See you on Monday.
Thank you, guys.
Bye.